When we are multiplying polynomials, just remember that everything has to get multiplied with everything. That's the main thing that's going to help you out. So I've got a 7 times 4. Actually, let's just rearrange these guys, right? 7 times 4 times x cubed times x. All I did was take this and rearrange the order. 7 times 4 is 28, and here I have 3 x's multiplied together with 1 more x multiplied together, x to the 4th. We would just write it like this normally, but that dot wouldn't make it wrong. Now, if you have an exponent, you had better do that exponent before you multiply. Don't forget that PEMDAS. We got to solve inside the parentheses, which we can't do. These are as simple as they go. Then we got to do those exponents before we multiply or divide. So let's first, I'm going to just leave this guy alone. I'm first going to square this, and then I still have to do the negative power. So I'm going to do this to the 1 over 9x squared, the reciprocal. Now, do you remember how to multiply fractions? I hope so, friends, but you just never know. So 15x to the 4th on the top, 9x squared on the bottom. Can you divide anything out? I would say we can take a 3 out of the top and the bottom. So we've got 5x to the 4th over 3x squared. And now that I am dividing these bases, I can subtract these powers and just have 2 x's left up there. Beautiful, all done. Okay, so bear with me for my silly problem here. What is 2 plus 3? It's 5. What is 7 plus 1? It's 8. We know that this answer should be 40, right? So let's look at how that really happens when we multiply this with it weird and broken out. I have to multiply everything in here with everything in here. So I have to multiply the 2 with the 7 and the 2 with the 1. I have to multiply the 3 with the 7 and the 3 with the 1. That makes it so that when I add them all up, I get 40. Okay? I had to multiply 2 with both 7 and 1. And I had to multiply 3 with both 7 and 1. Otherwise, I wouldn't get my whole answer. Same thing's happening here. This is really 5 times x plus 1, but let's look at it this way real quick. 2 times everything in there, 2x and a 2. 3 times everything in there, 3x and a 3. Combining like terms, I have 5x plus 5. Looking good. You're like, why are you doing this, Lindsay? I swear I have a reason. Here we are, multiplying 2 binomials. Bi is 2. There's 2 parts in this term, so that's our binomial. X plus 3, that whole term is getting multiplied with this whole one, x plus 1. Now, a common mistake here is that we say x times x is x squared, and 3 times 1 is 3, and we call it a day and say that we're done. But let's go back. What if I had done that here? What if I had done 2 times 7 is 14, and 3 times 1 is 3, 14 plus 3 is 17. I would absolutely not have made it to 40, which was the correct answer, because I missed all that middle bit that really matters. So coming back, not doing that very incorrect work, we're going to instead multiply this with everything over here and this with everything over here. This is also known as FOIL. You have to multiply the first parts with the outside parts with the inside parts with the last parts. So x times x is x squared, x times 1 is 1x, 3 times x is 3x, and 3 times 1 is 3. We add it all up and we get x squared plus 4x plus 3. However, another way instead of FOIL that I like, if you're kind of a visual person, is I just make a box. And I have x plus 3 and I have x plus 1. And now I'm essentially finding the area of each of these boxes. This box has one side that's x and another side that's x, so I multiply them, the area is x squared. 3 times x, 1 times x, 1 times 3, and now I add them up. And I had a student who called this the peanut method, which I think is like very funny because these, if you draw a little shape around them, it almost looks like a little peanut. 4x plus 3. Doesn't matter what strategy you use. What matters is you multiply everything on one term with everything in the second term. Okay, here we are again with my mess. 2 plus 3 is really 5. 5 squared is really 25. We know that's what we want at the end. So, can we do 2 squared plus 3 squared and be done? I hope that you're saying, no, Lindsay, no, what a mistake that is, right? Because 4 plus 9 is 13, which is extremely not 25. Can't do that. What we need is 2 plus 3 times 2 plus 3. We need everything multiplied together. I won't make you do all of the foiling on that one. But notice that 13, it missed the middle, just like before. So let's do it with an x. We have x plus 4 squared. What that really means is I have x plus 4 multiplied with itself 2 times. And now you can either FOIL or use the box method, whatever you like, and say we have x squared, a 4x and a 4x, and a 16. So altogether this should be x squared plus 8x plus 16. This is the part that you would be missing if you thought this was just x squared plus 4 squared. It's not. You have to get that middle bit in. Otherwise, you're changing the value of what this was asking you to do. So, general rule for anything that's in here. A plus b squared is always going to be a squared plus 2ab plus b squared. And that is because you've got your a squared and your b squared, and then an ab here and another ab here. You have 2 of them. If it helps you, if you're a person who likes memorizing rules, that's the rule. So just a quick practice. Foil it, box it, whatever you like, it doesn't matter. I can see I have 6x squared, 2 times 3 and x times x, minus 8x, plus 21x minus 28. Simplifying that down to 6x squared plus 13x minus 28. All right, let's do this practice. Multiplying my first ones, 16x squared. The next one's minus 12x. My next one's plus 12x. And then 3 times negative 3 is negative 9. Those 12x's cancel right out, and I have 16x squared minus 9. Now this is a special case that we will see a lot, especially when we are undoing this and we're factoring later. So let's take a deeper look at it for a minute. When you have a plus b times a minus b, so these terms are the same, these terms are the same, but one's a plus and one's a minus. Those are always gonna end up in the same form. We got a squared, we've got negative b squared. Here's a negative ab and here's a positive ab. See how these guys are always going to cancel out? So these are always going to be a squared minus b squared. This is called the difference of squares. It's a really helpful one to know and to kind of recognize when you can. So if you have something squared minus something squared, you probably got it by multiplying that a plus b times that a minus b.